Alright, back with another one. It's been a couple days and I've put some significant work into it. Nothing probably worth detailing. I'm going to go through here and show you what I've done, but nothing worthy of a detailed description, except for one thing that I want to get into, and that is the audio taper potentiometer. But first, on the enclosure, on the cigar box, I've got the input RCA type input jacks to receive the audio signal, and you can see I burned with a soldering iron left and right in there, and I've also burned left and right below the speaker binding posts. So that's really the only thing that's changed aesthetically. Again, this is a oddball, quirky amp, so I wanted to do things differently than what's traditional. So I opted to put the inputs on the top surface, and things are getting a little tight real estate wise here, but I plan to use this for kind of a desktop application. So because of that, I thought it would be good to have the inputs here, so that if if you want to unplug and plug in different sources, you could do it from a seated position without having to get up and look behind the unit. You could just do it right here, and without having to turn the thing around and unplug it or anything like that. So I thought it would be good to have it accessible from the top. I never like the ones that are on input jacks that are on the front surface. I want to keep the front kind of clean. So that's the reason for that. Just trying to think here, what else? Let me go ahead and set this down and open it up. And I've done some work on the inside, and I'll explain. Okay. So, oh yeah, I drilled the holes around the tube sockets. I wanted the ventilation holes, basically. I messed up one hole there, so I've got it patched with some putty, and I'm going to re-drill it. The drill slipped on me. These are all done by hand. I don't have a drill press. Actually, I do have a drill press. I just don't feel like getting it out. So these are all done by eyeball and by hand. So when you open it up, let's take a look at what's going on here. Let me get the schematic out. I don't know if you can see this, but it's kind of in light, but everywhere I've scratched out in pencil, I've already connected. And so I've got my line to the fuse, and this is the line that comes over to the fuse. Out of the fuse goes to this resistor R10, and R10 is our 12 ohm. I couldn't get a 12 ohm resistor. Let's see, this is 1 watt. I couldn't find one at a reasonable price in small quantity, so ended up buying these 3.3 ohm resistors. And I had to put, let's see, 1, 2, 3, 4, and then so 3 in series, and then the fourth one in series are actually 2 in parallel, and that gets me approximately 12 ohms. So that's good enough. That's not critical, not critical at all. But so these are soldered in, and oh, what else? Okay, you can see that we have 120 volts directly across the two heaters, the two filaments, and that's that guy there and that guy there. So I've wired that, so you can see when the power comes in, it goes to the switch, and then out of the switch it goes into this guy and it taps off. one of the 120 volts goes to the resistor, so one of the lines goes there, and the other one goes to the filament, and the other one trace it back, and that's this coiled wire, this twisted wire right here, and they go to the two filament pins, and then they loop back around, and the other side of the twisted wire goes to, I've got it temporarily taped right now for testing, but it goes to the ground, or the neutral wire, which is this guy here. I don't know if I had this before, but I got the speaker binding posts soldered, and here are the input jacks, and let me rotate this around and look at the other side here. Okay, so what else? Well, let's start from the input and work forward. These capacitors right here, there's a, you can call it a left and right, it's kind of arbitrary on the schematic, but each of the inputs goes to this capacitor C1, and I didn't have the proper value. It looks kind of ridiculous here. I didn't have the proper value for that, so it's supposed to be 0.22 microfarads, 400 volt. But what I did for each of the inputs is I had a parallel to 0.1 microfarads to get 0.2 microfarads. Each of these is a 400 volt cap. So that's how I had to do, and then from there, from the output of the cap, we go into R1 and R2, which are the ganged audio taper potentiometers, which is right here. So one cap goes to the top gang, and the other cap goes to the bottom. So those are soldered in. I do want to discuss audio taper potentiometers. I'm going to do that in just a minute. None of this stuff. I'm waiting for some parts here. For the balance control, I think I am going to eradicate that. I don't want a balance control because I don't want another potentiometer sticking out of this box. It's getting to look ridiculous as it is. So I think I'm going to replace the balance control with a couple of resistors. Let's see, that balance control, which is R5, is a 2 mega ohm pot. So that means that if it was adjusted to midway, then it would be 1 meg and 1 meg on either side. I'm going to replace that balance control with 1 megs, and just so I don't throw off any of the resistances that was designed into this thing. I don't know if it would make a difference, but the plate needs a reference to ground because this is cathode biased. So, you know, we have a reference to ground through this pot back here, but I still think we need these 1 megs in there, and I'm not going to change that up. I don't want to change any of the original design, at least not now. I'll tweak it later, but I want to build it first. So, anyway, over here I've wired up, I've got my positive line coming up through the 2 transformer primaries, and that's these red guys there and there, and then we go through this resistor R8, which is a 220 ohm 2 watt, and that's right here. By the way, this I normally use tag board for this kind of thing. I didn't have any on hand, and I was running out of money for the budget. I'm really strict on this budget thing. I really want to. Part of the satisfaction is building this per the budget. So buying tag board would have added another $8 to $10, which would have taken me over the budget. So I'm having to use this really cheap crap right here. But that's part of the challenge, is to actually make it work with this inexpensive stuff. So I just put this little resistor in a little holder here. I'm going to take a glue gun and glue over a little bit. But anyway, the resistor then branches off to the two suppression grids. Oh man, it's 3 in the morning. Is it? I'm tired. Is it suppression? It's a screen grid. Sorry. Branches off to the screen grids, or grid number 2. So this resistor here goes to one grid number 2, and follow this line over, it goes to the other one. So that's what I've done, and it's starting to look a little messy, but it's solid, and I've got it so that the top can be closed and all the wires will behave themselves when you close it. Okay, let me discuss, I want to discuss this audio taper potentiometer, because that's something that is kind of confusing, the need for it and actually what it does. And I want to talk about how to measure it, how to know you have the right taps on it when you're using it, what it does and why it does it. I think it's kind of interesting and worth a brief discussion here before I get too tired to discuss anything. So I'm doing this after work, so it's again, it's like 2, almost 3 in the morning here. Let me put this down, hit pause, and I want to describe this audio taper pot. Okay. Audio taper potentiometers. Absolutely necessary for volume control and even balance controls on audio equipment. And it all has to do with the way the ear works, the way we hear things, the way we perceive sound. Interestingly, before I get started, if you're listening to some sound through, if you're an amplifier and speakers, and you're outputting on average 1 watt of power, and you decide you want it louder, so you crank it up until you perceive that it's twice as loud. That's going to require about 10 watts. Now, if you want it twice as loud from that point, that's going to require about 100 watts. It seems odd, but it's exponential in that regard. And that's because the human ear has a built-in compression scheme. If you want to, I'm not going to get into engineering aspects of this, but look up the decibel system for sound pressure level, and there's some good resources on the web. But in essence, the human ear compresses itself. So on this axis here, I'm just going to have, how do I describe this without getting too technical, but hang on a second. Okay, visualize this axis here as being power. The power you're inputting to your stereo, or just the music, the acoustic power, it doesn't matter, just visualize it as power. And then on this axis here, visualize this as loudness. That's a terrible ear. As loudness, as you perceive the loudness. So at low power levels, you can start cranking up the power and you're going to perceive a big change in loudness. But as you keep going higher and higher in power, you perceive less and less of a change. For example, right here, that one little increment, you perceived a 50%, call this 100%, 50% change in loudness. If I go that another increment here, that's only another like 25%. And I keep going up, it gets lower and lower. This is like I was describing before. The reason it takes you know, from 1 watt to 10 watts, twice the perceived loudness, and then from 10 watts to 100 watts, another twice. The ear compresses sounds the higher the acoustic energy, and that's sort of a protection mechanism. At low sounds, you can distinguish very clearly low sounds from you know, intermediate sounds, and you know, common, you know, speaking and little nuances. But when you get into a loud situation, the ear compresses itself so you can handle it. You know, so you're not in pain, so you can still hear things in loud situations. So that's as technical as I'm going to get here for the purposes of this discussion. But it is interesting to look it up on the web, the decibel system, how the ear perceives sound pressure. Now, because the ear hears this way, if we were to use, let me go to potentiometers now. A potentiometer, which is what we use in and out. So you have some voltage in and some voltage out. And this is a resistor, as bad as it is. So as we vary that resistor, the voltage out is going to change. If the pot is all the way up here, then the voltage out will be equal to the voltage in. If the pot is all the way down here, then it's at ground, meaning the voltage out will be 0. So as we adjust the potentiometer, the voltage goes up from 0 up to the maximum it can go. Because basically this is a resistor, and it just slides, the output slides right across the resistor, changes resistance. Now, fine. If this potentiometer was linear, okay, now I'm going to change this graph to be rotation of pot, and I'm going to call this 360 degrees, all at one rotation. We'll call this 180 degrees, then 0 degrees, so rotation. And on this level here, we're going to have resistance of the pot. So at 0 degrees, let's say the potentiometer is at 0, meaning down here at ground, meaning no voltage out, meaning no volume. If the pot was linear, for every increment of rotation you would get an equal change of resistance. But that won't work well with how the human ear hears, because what will end up happening is as you adjust the potentiometer here, it's going to be too sensitive. An adjustment here is going to make too big of a change because the way you hear, too big of a change in the volume. It's going to be just slightly turning it up will just, you know, make it too loud. Whereas up in this region here, I'm going to have to sneeze. Up in this region here, the potentiometer won't be sensitive enough. So to compensate, this is a linear potentiometer. To compensate for the way we hear, we've got to have a potentiometer that behaves kind of just the opposite, like that. And this right here is the resistance curve for an audio taper potentiometer. So as we make rotational changes to the potentiometer, we get very little change of resistance down in this zone here. And the further we go, we start to get big changes in resistance for little rotations. That is the opposite of how we hear, which you combine an audio taper pot with how we hear, and you get a nice linear change. As you rotate the pot knob, you get a nice linear change in the output level, so it's pleasing to the ear. Okay, so you need an audio taper pot for volume controls and for balance controls as well. Actually, for balance controls, you use these ganged audio taper pots where they actually go in the opposite directions. I'm not going to get into that, but So what I have in my schematic here is I've got a dual ganged audio taper pot, meaning it's one potentiometer stacked on the other. One of them is R1, one's R2. They both behave identically. So when you install an audio taper pot, you've got to make sure a potentiometer has 3 taps. Let me kind of draw it the way you see it on the potentiometer. It's got 3 little tabs. And the 2 outer ones go directly across the main resistor. In my case, this pot is, I'm using a 1 mega ohm pot. And then the middle tab is the wiper. So if you measure the resistance between the outer tabs, you're going to get the resistance of the pot. If it's a 1 mega ohm pot, you're always going to get 1 meg or close to it. Now, how do you know, if you just have a potentiometer laying around, how do you know if it's an audio taper or a linear taper? Unless you know how to read the codes on them, which I don't. There's a really neat trick for that. So what I'm going to do is show you. Well, let me show you on paper first, and then I'm going to actually do it. If you have you take your ohm meter, and if you were to put your ohm meter across the 2 outer tabs, you should measure the resistance of the pot. We just talked about that. But if you go between the middle tab and one of the 2 outer tabs, and you rotate the pot to its center position, rotate it around and get it right in the center. If it's a linear taper pot that follows this curve here, then the resistance you should read should be half of the potentiometer value. In this case, it should be 500 K ohms. If it's linear, because look at 180 degrees rotation, we're halfway up on the resistance. However, if it's audio taper, you should be getting something a lot lower than half. See, it follows this curve here, so coming over there, the resistance will be a lot lower than half of the resistance of the pot. So I won't even run through it. I think that's a good enough explanation. I won't show you on my potentiometer, but that's how you do it. So in order to, when you go to install the pot, you got to make sure you go between the right 2 connections, and you want 1, 2, and 3. Let's say. Well, 1 and 3 are going to be those 2 there, and that's going to be number 2. And that's how you want to make sure you hook it up, so that when the potentiometer is rotated all the way to the left, which is usually your 0 position, then the resistance should be close to 0. And that's how you know which of these 2 to use. So I won't even show you on mine, but that's how it works. So okay, just interesting stuff about potentiometers. Volume control, balance control would be the same thing. If I was going to do a balance control here, well, this is actually linear. This balance control uses a linear pot, wouldn't it? That would get kind of funny, but they make balance control pots for using an audio taper kind of thing. But I'm not using a balance pot. Like I said, I'm using the 1 megs instead, so I'm going to bypass that. Alright, I think that's about it. Let me just see if there's anything else. No. That's the progress I've made so far. Close this thing up. Take this off the tripod. Sorry if my explanation wasn't so good. It's always doing this stuff late at night when I'm tired as hell, but alright, so there's where we stand. Again, these, I talked about this earlier, but these little holes, you know, holes can be a form of strain relief. Also, you know, if there's a portion of a metal plate that's going to get a lot of flexing, like, you know, you're pushing on it because you're pushing the tube in or pulling it out, you can put holes in there to prevent cracks in the metal. But the other function they serve, again, is natural convection. So as these tubes heat up, heat's going to be drawn up like that. It's going to create a very small vacuum around these holes and draw heat out from the inside of the tube amp. And I need to put a few holes on the bottom to allow cool air to go in, just to get the whole natural convection process going. Not that there's anything inside this amp that's going to heat up that much. There are a couple of power resistors. Be a very small amount of heat, but it still needs a place to escape. So the amp will draw in cold air from the bottom and convect up through these holes by the convection of the tubes. It's an interesting process. And again, I drilled these holes by hand with a drill. You can see they're not perfect. That one there I got to re-drill, but it's good enough. The whole point behind this amp is it's not perfection. Also, I am not the best at soldering. I do my best, but I've got bad eyesight and a shaky hand, so I'm just happy to be able to solder anything. So I'm not going to be discussing soldering techniques or anything like that because I'm not the one to ask. Also, I'm not trying to be, you know, provide the last word in immaculate wiring in here. I'll leave that elite stuff to somebody else. I just like getting the job done and making sure there's no interference. You try to run the power lines not in parallel with any of the signal lines and keep them away from each other as best possible. It's going to be a challenge here because, again, we're dealing with a chassis that's not earth grounded. But you know, I do my best, but I'm not going to tout my workmanship here, especially for this amp. I've built a couple of gems in the past where I try to be as immaculate as possible, but I'm not trying that on this one. But it's pretty good. It's not bad. So thanks for watching. When I get some more work done, I'll provide another video on this, but I don't think there's anything else. Oh yeah, you know what? It's actually, hang on. It's actually ready to hook up and at least watch the tube heaters glow. I think I can do that.
This is a review, broadly speaking, that's been underway for some time. He's had a number of meetings with people conducting close examinations.
Hang on a second. Let me just look at something, make sure I'm not going to blow anything up doing this.
Tighter restrictions on foreign leader spying, and is also United States played a critical role in getting the world.
Okay, I'm going to go ahead and get my tube sock out and pop the tubes in.
One of the most fragile democracies is in danger of shattering.
Let's see.
1,000 people have been killed after a political
One
struggle
tube.
ethnic violence. Thomas Green,
I don't have it on a tripod right now, so I'm just going to have to talk. I'm just putting the tubes in, and I'm going to get a variac out. I think everything's looking good to at least fire the tube heaters, the filaments up, and watch them glow.
California's governor says the nation's largest
I'm just getting the variac.
finally turned the corner. Scott Dentro of member station KQED reports Governor Jerry Brown wants to increase California's spending by more than $8 billion.
During the depths of the recession, California was cutting spending by tens of billions of dollars. Now the state has a multi-billion-dollar surplus, and the always cautious Brown wants to increase spending.
Okay, so I've got the amp plugged in. Turn this off. Plugged into the variac. turn the level all the way down. Okay, variac is on. And we're going to slowly crank up the voltage. So again, the line voltage right now is 0. I'm going to slowly bring it up to 110. I don't hear anything. I don't hear any crackling or popping, or the variac didn't blow its fast blow fuse. Okay, we're now at 110, which means the tubes are, I'm feeling for heat. I'm going to have to go turn the light off and see the glow. Let me get this light turned off. Okay. Oh, well, what an idiot. Okay, I'm officially an idiot. I didn't have the switch on. So, here's what we got to do. You idiot, you idiot. Yeah, let's put the switch in. This is a little key switch. Now it's on. Duh. Okay. You idiot. You idiot. Oh boy, okay. Here we go. Let's try that again. Cranking the line voltage up to 110. Okay, there we are. And I see glowing. And I feel heat. I'm going to go turn out the lights and bring the camera over here if I don't trip over something. Oh man, I can't see anything. Here we go. This is my Fisher receiver. Beautiful. Nice beautiful glow in the dark. Oh, look at that. I don't know if this camera's going to pick it up or not, but there they are. Look at that. There are the tubes right there. It's the first time these things have glowed probably since they're new old stock, so probably 50 years. Sitting around, and they got a beautiful glow to them. This tube glows bright on the bottom and the top. You can see the really, really nice. That's what I love about tube amps. So they're looking good. Beautiful. Okay, now I got to find my way back to the light switch. This is why you don't leave things laying around on the floor. Alright, well. Guess what? I can't find the light switch. I'll just show you my Fisher while I'm looking for it. Good gracious. That took a while. I was feeling behind this thing. There's the light switch. Oh, duh. Okay. So that's all I have for tonight. Let me turn this thing off. Turn off the variac. And one of the things you do is I plug everything into one power strip, and that way you can hit one button and make sure everything on your bench is turned off so you don't forget anything like soldering irons. And this is my soldering iron. This is one of them. I've had this. I bought this at Radio Shack back in the 80s. That's right, the 80s. It's got a 30 watt and a 15 watt on it, and it's cheap. It's a piece of crap, and I love it. And I also, for higher power soldering, I use this thing right here. And then for ridiculous soldering, I use a gun. Yeah, that's for brute force stuff right there. You don't use that on circuitry generally. I've had this thing, again, Radio Shack, from the 80s. They still make them and sell them. This is my flux remover pen. Rosin soldering flux right here. Let me tie that up. And whenever I'm cutting and crimping, and I save wires and put them all in this can, I save pieces of heat shrink that, you know, you can still use the stuff over and over again. I try to keep them all in a little can here, especially on this amp where I refuse to go over budget, which, you know, I don't have a dime more to spend, so I've got to use everything. That's why a lot of these wires are different, strange colors. You know, there's not a consistency of colors. Fortunately, it's easy to trace the wires through this thing, but there's no color code in here except for red. Red is always power. You know, I'm just using wires where I have them. Alright, thanks for watching. See y'all again. Night.